Good afternoon. Today we will solve branch and bound algorithm. So we will solve a problem using branch and bound method. So let us consider the problem. Max f is equal to 3x1 plus 4x2 subjected to the constraints 7x1 plus 11x2 less than or equal to 88, 3x1 minus x2 less than or equal to 12, x1 and x2 should be greater than or equal to 0 and are integers. See, we know that for the integers linear programming we have two methods. One is Gamori cutting plane algorithm. The second one is this branch and bound algorithm. So this branch and bound algorithm uses actually the graphical method, and the Gamori cutting plane algorithm uses a simplex methods. So both are used for actually integer linear programming problem, and so we'll see how to solve this using this branch and bound method. So first thing is, in the graphical method, to solve using the graphical method, we have to, instead of this less than or equal, we have to equate it. So I'll just divide this into three sections. So here I'll be drawing the graph, and here I will be representing these values in terms of the nodes. So first we'll consider these constraints. 7x1. First consider the first constraint. 7x1 plus 11x2 equal to 88. Then let consider x1 is equal to 0. If x1 is equal to 0, what is x2? x2 is equal to 88 divided by 11, you will get 8. So one point here is 0, 8. Then let consider in the same equation x2 is equal to 0. If x2 is 0, what is x1? So x1 is equal to 88 divided by 7. So you will get here 12.57. 12.57. So these are your 2 points. 12.57, 0. This is your 1 point now. Let us consider the second equation. So I'll just mark this as the first equation. This is equation number 2. So let us consider the equation number 2 here. 3x1 minus x2 equal to 12. Again, let consider x1 equal to 0. Then what is x2? x2 is equal to minus 12. Okay. Then let consider x2 equal to 0. If x2 is 0, what is x1? x1 is equal to 12 divided by 3. You will get 4. Now here 0, minus 12, and here 4, 0. These are the points. Now we will draw this one. Roughly I will draw. You can use actually the graph sheets here. Now roughly I will draw these points. See, this is one set of the points. This is one more set of the point. So this is my x-axis. This is my x2. This is x1. This represents x2. And all the units here is represents 2, 4, 6, 8, 10, 12. So 2, 4, 6, 8, 10, 12. So here minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. What is our first point? 0, 8. x1 is 0, x2 is 8. One more point is 12.57. It is almost 13, comma, this is somewhere here and y is 0. So join this. Okay. And what is the equation here? 7x1 plus 11x2 is less than or equal. So whatever the point, it should be less than this range. Okay. Then second equation, 3x1 minus x2 is less than or equal to 12. What are all the 2 points? x1 is 0 and x2 is minus 12. So this is 1 point. One more is x1 is 4 here and y is 0. So join this like this. Now what is the conditions here? Less than. So all the points or your value should be within this. Now what is the feasible region wherein your value may reside? So these are called as feasible regions. Only these are called as feasible regions. What is the point here? x1 is 0, x2 is 8. And here what is the point? 0, 0. And here the point is 4, 0. x1 is 4, x2 is 0. What is the point here? This is the intersection of these two equations. So to find out the value here, what you can do? You can solve these two equations. So solve this equation. So 7x1 plus 11x2 equal to 88. Then I'll just multiply here 11 so that this becomes 11 and 11 so that we can cancel. So 11 into 3, 33 into x1 minus 11 into x2 equal to 11 into 12. So 11 into 12 you will get 132. Now if you solve this equation, you will get 40x1 equal to 220 and x1 is equal to 5.5. So this point represents 5.5. Then substitute this equation in any one of the equation. Then you will get x2 is equal to 3 into 5.5 minus 12. So x2 equal to 4.5. So one more point here is 4.5. Now what it indicates? This is one intersection, this is one intersection, this is one intersection, this is one intersections. And it says that your value may reside within this region, any of within this region. Now if I solve here the objective function f, 0, 8. So x1 is 0, x2 is 8. So 8 4s are. So you will get here 32. Objective function is 32. And if you apply here 4, 0. This is 4, this is 0. So you will get only 12 here. And if you substitute this x1 and x2 value in the objective function, here you will get f is equal to 34.5. Which is maximum here? Objective function is maximization. So which is maximum among 32, 34.5 and 12? This is the maximum value. So we will be considering this in the first step. So I will write here f is equal to 34.5. x1 value is equal to 5.5. x2 value is equal to 4.5. Now, since this gives me the highest or the maximum, the value for f, whether we can consider this x1 and x2, we can't consider because it says both x1 and x2 should be integers. So, now we have to branch this to get to the to get the integer value. Since both are here as fraction, whether to select x1 and x2, so I will go for the maximum value. Maximum value here is x1. This x1 value resides in, this is x1 value 5.5, value resides within 5 and 6. Correct? Now I am going to branch it because I want to get to the integer value. So this value lies between 5 and 6. Now you have to use the constraint x1 should be less than or equal to 5 and x1 should be greater than or equal to 6. So this is how we have to continue in case of the branch and bound. Now along with these equations, we have to consider this case as well as this case. This helps you to limit actually the your answer within a region. So that is why we'll be calling this also as a bound. So we'll see next how to solve by including this in these equation, this in these equations. Include this equation here along with this, include this equation here separately. So I'll write this again, max f is equal to 3x1 plus 4x2 subjected to the constraints 7x1 plus 11x2 equal to 88 less than or equal to 88. 3x1 minus x2 is less than or equal to 12. Now separately we have to consider this. In first case, along with this, x1 is less than or equal to 5. Here second case, x1 is less than or greater than or equal to 6. Again you solve this. So now from this equation we got the point as 0, 8, 12.57, 0. From this equation we got 0, minus 12 and 4, 0. Correct? Same thing applicable to here also. This equation says x1 is equal to 5. So this equation says x1 is equal to 6. Rest all these points is applicable to here also. Now again you draw this using the graphical method. Now here 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. Minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. Approximately. You can draw this in the graph sheet also. So here 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. Here minus 2, minus 4, minus 6, minus 8, minus 10, minus 12. Draw. 0, 8. 0, 8 will be here. 12.57, 3. So approximately you have to join like this. 0, minus 12. 0, minus 12 will be here and 4, 0. 4, 0 will be like this. So you have to join like this. And here your value resides within this portion. So this portion is called as feasible region. So here also 8 here and here 13. So join this. Next minus 12 here and 4 here. So join this. This region is called as feasible region wherein the value may reside. Now here I have to, along with this, we have to consider the constraint x1 is less than or equal to 5. So to make it equate, to solve, we will be considering this as a x1 is equal to 5. x1, and this is your x1, this is your x2, this is your x2, this is your x1. So x1 is equal to 5. So x1 is equal to 5 will be somewhere here. So draw a line like this. And what is the constraint? Less than. So again you are restricting the area. Now your value should reside within this. Within this you have eliminated this portion. Okay. And this area, and this area. So this region is called as feasible region wherein your value may reside. And now, so this point is again 0, 8. We have seen what is the objective function value. F is equal to 32. Now, this also we have seen 4, 0. The value of objective function is 12. We have seen in the previous case. Then we have one point here and we have one more point here. We have to find out. How will you find out the value here? See, to find out the value here, you have to see from you have got this intersection from which two of the equations. See, one equation is this one, first one. So you have to solve 7x1. For example, I will solve here 7x1 plus 11x2 equal to 88. And how did you get to this intersection? From this. What is this line? x1 is equal to 5. So you know that x1 is equal to 5. Only thing is you have to find out x2. So x1 is equal to 5. So just solve this one. So, substitute x1 in the place of x1 you substitute 5. So if you solve this one, you will get 4.818. So this equation indicates 5, 4.818, and just substitute this x1 and x2 value in the objective function. F you will get 34.27. Okay, and we have one more intersection here, intersecting point here. What is the value here? Again, to find out from which of the two equation intersection you got this. See this line. What is this line indicates? This line indicates equation number 2. Solve this one. 3x1 minus x2, and what is one more equation? This x1 is equal to 5. Just substitute in the place of x1 is equal to 5. So I am sure one of the value is 5 here. What is x2 value? Substitute x1 is equal to 5 here in the second equation. Find out x2. You will get here 3. What is F? F is equal to, you will get 27. So from the next, this iteration, what did you got? 0, 8, one intersecting point. F is equal to 32. Now, from the first iteration, what did we got? X is the maximum value of the objective function is 34.5. Okay, so within this, and here we got this. So the objective function is 34.27. Among this, the objective function is 27, and here we got 12. So which is maximum among this? Maximum among this. This point gives you maximum value for your objective function. So retain this. So in this equation, your value of F is equal to 34.27, x1 is equal to 5, x2 is equal to 4.818. I hope you understood. So I have considered this. Now what I have to consider? x1 is greater than or equal to 6 here in this case. So now where is x1? x1 is here and it should be greater than. So I will draw a line here. This line should be greater. Greater indicates it's away from the origin. Now see, this indicates your feasible region should be this one, but your third constraint says it should be away from the origin, this. So if you will not find any common region. So this case is called as there is no feasible region. No feasible region. Okay? Why? Because the first two constraints is your value resides within this location. But when you added the third constraints, it says it should be away. X1 value should be greater than 6. So we have to look into the region beyond the 6. If we look into the beyond this, we won't get any common region. That is why this region or this is called as there is no feasible region. So if I consider this, there will be no feasible region. Okay. Now, then can I consider this itself as a the values of x1 and x2? No, because again I have here x2 is equal to in terms of fractions. So again I have to convert this into integers. So x2 value, x1 is integer, so no need to worry. X2 is a fraction. So consider this x2. Consider this x2. X2 value is 4.818. This value reside within 4 and this value lies between 5. 4.818 value lies between 4 and 5. Again, this is x2 value. So just add the two constraints. X should be less than or equal to 4. X2 should be greater than or equal to 5. Now what you have to do? From the first one, all these constraints. Second one, you may find the feasible region or the optimal value in when you included the x1 is less than or equal to 5. So we have to include this, and we have concluded that we no use of including this. Now again I have to consider along with this one now. X2 is less than or equal to 4. X2 is greater than or equal to 5. So we'll see how we have to include this and which gives you the best solution. So we have to consider this equation along with this now. X1 is less than or equal to 5. Here also x1 is less than or equal to 5. In this x1 is less than or equal to 5, we have to consider now two cases. What are all the two cases? X2 is less than or equal to 4 and x2 is less than or equal to 5. Again draw the solve using the graphical method. So 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. 2 minus 4, 6, 8, 10 minus 12. Here 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10, 12, 14. Minus 2, minus 4, minus 6, minus 8, minus 10, minus 12, minus 14. What are all the points here? 0, 8. This is your x1, this is your x2. x2, x1. 0, 8. 0, 8 is here. 12.57, it's almost 13, 0. 13, 0, 13, 0. So join this. Join this. Then 0, minus 12. Minus 12 is here. Minus 12 is here. 4, 0. 4, 0 is here. So join this. What is the one more conditions we have to consider now? X1 is equal to 4. X1 is this one, equal to 5. So 5 is somewhere here. X1 is equal to 5. Here also x1 is equal to 5. Okay, so it should be less than. So the value resides within this. Value resides within this. Okay, feasible region. Then x2 is less than or equal to 4. x2 is here, less than or equal to 4. 4 is here. So you have to draw a parallel line to the x1. So again you have narrowed down. Now your feasible region should be within this. Only now the region is these values. Okay. Only these are your feasible region. Then here x1 is equal to 5. So this one, x2 is greater than or equal to 5. So x2 is 5 is here. x2 is greater than 5. So 5 is here. So somewhere here. Okay, greater than indicates above this. So now what is your feasible region? Only this is your feasible region wherein your answer may reside. This is your feasible region. Here this is your feasible region. Okay, find out the values. So what is the point here? It's 0, 8. What is the objective f value for 0, 8? The f value is equal to, we have calculated already, 32. Okay, here it is the 5, 0, 5. For 0, 5, what is the value? Just to substitute here. x1 is 0, x2 is 5, 4 5s are 20. So f is equal to 20. And which is your one more point? This is your one more point. So how will you get to this point actually? Here you have got this point from the intersection of this as well as this as well as this. This indicates 7x1 plus 11x2 equal to 88, and it says x1 and x2 are both are 5 5. So here both are 5 5. Why 5 5 here? Because you can see here x1 is equal to 5, x2 is equal to 5. So you will get here 5 5. So what is your f value? F value equal to, if you substitute here 5 and 5, so it will be 15 plus 20, 35. F is equal to 35. Now, we'll solve this also, then we'll decide whether to select which is the point we have to select here. Now, what is this point here? This point is 0, 4. What is f value for 0, 4? It is 16. Then here, what is the point here? This point is 4, 0. What is the f value? It's 12. Now, you have here, you will get here, if you properly using the graph, if you do, you will get here 2 points. So, this point will be 5, 4 and this point will be 5, 3. Properly draw using the graph sheet, you can find actually 2 points here. So you will get f is equal to 31. Here you will get f is equal to 27. Now, select which is feasible and optimal. So if I consider x2 is less than or equal to 4, what are all the points I will get? 0, 4. F is equal to 16. So what is our expected almost the objective function? 34. So it is less. So we'll leave this. And here, this 5, 4. If you consider, you will get 31. Here 5, 3. If you consider here 27. And here 4, 0. You will get 12. So which gives you your maximum objective functions within this region? This 5, 4. F is equal to 31. So here the value will be f is equal to 31, x1 is equal to 5, x2 is equal to 4. If I consider x2 is greater than or equal to 5, what is the value I will get here? Then, see here 0, 8, f value will be 32. And here f is equal to 5, 5, f value will be 35. But you can see here, what is from the first equation, what is our expected, the objective function, but it is not in terms of integers. So, 34.5. So, this is crossing that line, so crossing that limit, so we should not consider this. And 0, 5, f is equal to 20. So, which we can consider among this? We cannot consider this because it's crossing this limit. So, we can consider 0, 8. f is equal to 32, x1 is equal to 0, x2 is equal to 8. Now, since I got all the values here in integers, just to decide which the integer value we have to consider. Now, see, f is equal to, you cannot consider this because you have a fraction here. You can either consider this or you can consider this. Here your objective function is 31 within this value, f is equal to 32 within this value. So both are integers. So we can consider this as our final answer. So final answer is equal to x1 is equal to 0, x2 is equal to 8, f is equal to 32, which is the best optimal solution for this particular problem. Thank you.
Reva University, one association for many great careers.